thanks everybody for joining us. This is just meant to be a intro type session here, as this is the first of our seminar series for the spring semester. Just wanted to quickly go over as a reminder on the SpaceVT website. We do have information on this seminar series listed here as a convenient link right at the top, as well as a calendar for presentation slots. And just a note on that, we actually do starting to have these fill up. So I think we are actually now, including this one, we are now a quarter of the way full for the semester. It'll start going by pretty quick once we do just every other session. So I certainly urge you, if you would like to make a presentation, to email me, and we'll get you added to our calendar. And I guess on that, otherwise too, the one thing that's on here is all these you can, and previous ones you can check out on our YouTube channel, as well as other videos and things like that. So I've got the ones for the fall semester kind of made in a playlist to help organize them for whatever it's worth. So let me stop sharing that and then start sharing our presentation for today, if I can find it. Now I've got the PowerPoint up. No, I won't. Let me share. Let's see. Well, let's try this again. There we go. There it is. All right. And so yeah, this is just meant to be as a overview of the SpaceVT Center for anybody that's new. I'm seeing maybe a few new names, but certainly this will be a kind of old information, or certainly it does give, for those who've been around for a while, is going to give some kind of maybe updates and kind of insight into what's going on. So my name's Kevin Sterne. We're a research associate with the SuperDARN HF radar lab here within the SpaceVT Center. And we'll jump right into it. So yeah, so certainly the world is really changing and really kind of growing. I think we're going to see that some here, even through the first couple of months. I'll have something more on that here in a little bit about, in space, right? So we'll see some too on CubeSats, especially ones that are going to be launched. And then there's other other planets that are being explored. One of the big things, I'll maybe jump right into it, because one of the big things that I'll be curious on is the Perseverance. It's a Perseverance rover, I think, or the Perseverance mission, which is I think a set of probes and rovers or whatnot that's landing on Mars here actually within the next month. One of those probes, I've been seeing a couple of information. I need to read some more on it, but they I think they're gonna have a microphone, so we'll be able to hear what Mars sounds like, and as well some kind of like helicopter drone probe type thing that will be able to fly around and collect samples. So and certainly you can see here space weather is what kind of a big key to a lot of things about understanding our environment around Earth, especially when you talk about CubeSats, which was one actually I just had a presentation by a researcher at NASA who had reminded me or brought to light of something with all these CubeSats that are going up, especially with like SpaceX's Starlink and other things like that. They're being put up right now in solar minimum, where the Earth's the environment around Earth, kind of in the closer orbits, is a little bit more benign. And so what happens to a lot of those CubeSats as we approach solar maximum in the next 4 to 5 years? And I guess it's not necessarily CubeSats, but also like the small sats and things like that. He was talking about, with these smaller CubeSats, the planning stages for them for launches, kind of where we'll be at. Solar max is starting now. So that's something to kind of consider, that it maybe hasn't been as big of a factor before. And in particular, the presentation that they had a little bit earlier was talking about shielding and radiation rates. So, which that of course is a huge thing once we start getting into more this solar active or picking up, I guess, on solar activity. So let's see. So of course, that's all good and fine, but what's the fun, pretty pictures that we could see? Of course, one of the best manifestations that we see with space science and things with solar storms is the aurora borealis and aurora australis, the northern and southern lights. So it's in SuperDARN, this is kind of comes up as a handy example that I kind of try to relate to friends and family who aren't as familiar with it. But of course, too, charged power electronics, power grids and coils are another good fun thing. Fortunately, the last solar cycle wasn't, I guess it's sort of fortunately or unfortunately. Fortunately, there's no damage. Unfortunately, that kind of makes our research seem a little less pressing, I guess is a good word, but nonetheless, solar storms can have a huge effect on electrical grid systems. And then as well as talking about, with satellites and the radiation environment, that especially more sensitive electronics on these satellites might need protection from. So SpaceVT, jumping into kind of where we fit into that, or what we're kind of trying to do in a broad sense, is mostly trying to understand a lot of those processes. A lot of them are still trying to be figured out, and trying to figure out how the Earth's magnetic field and the layers of the atmosphere that are around it kind of respond to changing conditions from the sun and the solar wind, and then especially in how we can then apply that into satellite development, and making sure that you don't fly a satellite or you don't launch a satellite and then the next big solar storm that happens, all the electronics just go kaput on it, and that kind of thing. So otherwise too, a big component, that's fine and well. We could do that anywhere. We could do that at a big engineering house, but why at Virginia Tech? And of course, this is the intersection of doing that kind of research and novel thinking, but as well getting students involved, right? So part of it is to train all the wonderful grad students and undergrad students that we have involved in our center, and let them kind of expand their knowledge on that, as well provide them, and that then provides a better, once they leave us, or some of us that leave us, I myself went through one of the labs here and just never left, but many of the students, leave, and once they do, then they're able to go out into the workforce and do good work as well. So, and of course, too, enhancing the diversity of this field, and providing it from a diverse background that we try to strive for at Virginia Tech, and as well as at SpaceVT. A little bit more on the numbers and nuts and bolts and things. This is a group picture that's non-complete. As you can see here, we're saying, we've got about 30 professors and research faculty in various kind of levels and forms of those, between 3 different departments of electrical and computer engineering, aerospace and ocean engineering, as well as mechanical engineering. And so you can see there's a little less, the number of that here, but this is a decent representation of what we had, as well as our graduate and undergraduate students. I could think that the numbers here would be a lot bigger as I look over it. This is much more capturing graduate students. If we had undergrads in this as well, the picture would probably have to be twice as big. And we'll go into this a little bit, I think, on the next slide. Of our general expertise is space and ground-based measurements, collecting data, and then going into that data and doing the analysis on it, forming it into or applying it to theory, and as well applying it to theory, as well as trying to come up with new theories, and then is a whole other department of computational modeling and theoretical kind of development from that. So, and as we're seeing too, one other thing that we're starting to get to is actually some space flight and kind of space assembly. or not in, which is not in space assembly. I guess it's more of spacecraft or space, CubeSat assembly and testing type thing. Here's a listing of our core research groups. We'll start, top here and work our way through these in expanded form. But this gives you a general sense, and this is certainly not complete. And there's probably a few things here that even in the last couple of weeks that we might be adding to this. So we'll dive through each of these here now. First of which, let's see if I can get some of these cool videos playing for you guys, as our space plasma modeling and simulation. So it's saying if we have a representation, a theoretical representation or model of the Earth's magnetic field, and then we apply some kind of solar shock or a magnetic field shock to it, what happens? And this is a model simulation of that result. This is a very neat thing. As you can see, it seems like it's fine, and I think, yeah, you see the pressure front there, and something to show you too of a lot of our grad students and researchers that will be watching this could probably talk on hours about all the different things that are going on. There's a lot of different things that we could kind of highlight just from this one simulation of that's shown in here. But a lot of it's kind of listed here on the bullets on the left side. I'm going to play this one here as well to show you that. And a lot of this goes back to why is this necessary, and a lot of it relates to that last bullet, or the last two maybe, is the propulsion and plasma kind of environment. So the plasma will have some kind of excitation or radiation type characteristics to it that can affect more sensitive electronics on board, as well as the propulsion, and some of that too getting into even the atmospheric drag models, which I think is something that's not quite listed here. But how does the drag on a spacecraft, is it slowly decelerating on its orbit change because there's different composition of ions, or more things are disturbed at lower altitudes, and that's one of the kind of research areas here. One that I could talk on for hours, because this is one of my lab, this is my home lab, is the SuperDARN HF radar lab, and that stands for the Super Dual Auroral Radar Network High Frequency Radar Lab. So the Dual Auroral Radar Network is a way to say that we at VT are a collaboration, or just one of almost a dozen institutions around the world operating up to, I think, are up to more than 35 radars at the moment. And that's both in the northern and southern hemispheres. And that's because most of what we're measuring happens around the poles, but we do have some thoughts of trying to expand that into, we have so far into mid latitudes and even into lower latitudes. So you see the picture of the radar site here in Kansas, which I've gone to many times. It's my job to make sure these are all working. It shows there are two radars here, one off to the northeast and one off to the northwest. These are quite large. This is about 30 by 30 foot building. So each length of this is about 700 feet long or so. So it's quite a massive system. What it does is it's used for remote sensing of the Earth's ionosphere, namely in the E and F regions, or F layers, and studying what's going on in those during solar storms and just general, and also when there's not solar storms, right? Because a lot of times there aren't solar storms happening, and so we also get a lot of good data when there's nothing, when there's not, the atmosphere is not particularly disturbed. So we also have a good bit of kind of HF radar technologies, and I think that's where I'm trying to say is that bleeds into just some HF radar technology of just remote sensing. One interesting project that started with a doctorate student here was searching or looking at sea ice. Actually, we could sense when the northern hemisphere, mostly in the Davis Strait around Greenland, and well in the Hudson and James Bays, when those iced over and froze, we could actually sense that with these radars. So again, I'll try not to talk too much, but last little bullet is that here at Virginia Tech, we're responsible for 5 radars, 2 of which here in Kansas. Another one of them is in Blackstone, Virginia, which is outside Richmond, and then 2 in Canada, one in Labrador and one in Ontario. The next core research group here is the MIST team, or the Magnetospheric Ionospheric Science Team. And this is a NSF and NASA funded team which installs, maintains, and operates magnetometer sites that are largely independent. And they're taking a couple different, the ones that we have here are down in Antarctica, I think based largely out of South Pole Station, and then strung out, you see these PG labels here, kind of where my cursor is going. Those are the ones that VT operates, in which you can see one of them here, I think near South Pole Station, because I can see some kind of facilities kind of around in the background. And these are largely autonomous. These are largely, I think one of the, they call it an ALPIP system. And one of the A's there is an autonomous, because you can imagine when you're not near a large supported facility in Antarctica, there's no hardware store, there's no, even like a grocery store or whatnot. So to go out and install and maintain these systems is a huge undertaking. And to where it takes several flights just for all the equipment to be taken out there, and sometimes all the fuel that'll be needed to make the return trips and everything. So a lot of these the other things is other magnetometers is also looking at GPS scintillation as you're moving kind of across this array of instruments. So I think they're up to 6 or 7. I know we've got a number of the grad students who work on a lot of these, so we'll save the comments for the end, and if there's anything to clarify, we'll certainly get those in. I'm certainly not the most knowledgeable. The grad students and researchers that might also be on will have better understanding. So one of the next core research areas are space and ground-based kind of aeronomy or remote sensing. This is a big thing to our directors kind of research area, Dr. Scott Bailey, where you can see on the right here where they've put optical instruments into sounding rockets and gone up to Alaska and at the rocket range there in Poker Flat, and launched a sounding rocket up, and then looked at how light waves, or the basic study is about the chemical composition of certain layers of the atmosphere, and certainly in certain places, around the northern or the North Pole, where the Earth's magnetic field lines kind of become open. They just kind of go into the to space and don't come back to Earth at all. And so they're using a lot of things like stars and the moon, and there's another one that you see on the bottom right here that was called GLOW. That is using, that one used the sun actually. And the idea is that you use those as your light sources, and then you look at an instrument and see how those light waves are disturbed as they're going through different kind of different masses of certain chemical composition, or masses might be a wrong word there, or kind of wrong phrasing, but grouping, I guess, or blobs, and maybe is a very non-scientific term. So yeah, you can see that a lot here listed on the left side. So, another core research areas are kind of in situ, or kind of at the place of measurement for space plasma. One of the big things that's been ongoing for quite a while is the LACE mission, which is a 6U CubeSat that should be launched this year and deployed off the International Space Station. That one's been going through a lot of revisions, so that's why there's a question mark that we think it's going to be launched this year. I don't know if it has gotten a confirmed launch date, but maybe watch our other seminars or certainly our LinkedIn and see some more updates on that. So, in this too, again, that's a CubeSat version of that, but as well, we've done a lot of sounding rocket missions. Sounding Rocket 2, not just for research, but as well a very large student-led team with the RockSat team. The RockSat program is a program where students completely come up with the idea and build a sounding rocket payload that gets launched out of Wallops Island over on the eastern shore, and they can do a number of any projects that they want. One of the ones involved just kind of launching out little circuit boards and then having it transmit back to the to sounding rocket to take certain measurements. So we also too in kind of simulator type stuff is an attitude control simulator where we've created a Helmholtz cage that looks very similar to this one. And the idea is that then you put your CubeSat in the middle of that and you simulate an orbit or what the Earth's magnetic field would look like in an orbit around the Earth, and how your attitude control system on your CubeSat performs, and how do you need to kind of cope with that changing magnetic field. Last core group here that I'll talk about is the kind of space systems control and general GPS or GNSS group. And this is a very similar thing about that Helmholtz cage, which is I guess the idea here is that this is more of a kind of testing part of it. And then once we move on to actually building a piece of hardware, that's where that same simulator kind of comes into play for that. So I've also done a lot of space situational awareness type research, where in the lab you can simulate maybe spacecraft formation flying with substituting that out with drones, and having a drone kind of reading off what it's seeing optically and where its position is in the relation to something else, and making sure that if its home, landing spot moves around, that it can go over and figure that out, as well as kind of avoid, certain targets, or if you have it circling, as you see here, if you have it circling kind of a central object, and if that object suddenly moves, that it'll change to its kind of orbit around that, or its kind of flight around that, so that it also moves along with it. And then lastly, there's and this is going to be changed here in the coming future, but the basics of it will stay the same, is that we have a large GPS, and as well, there's GPS is the US version, but we can also simulate a lot of other global navigation systems from around the world. And this is useful with this kind of how it relates back to the space science part of it, is that far right box where you have some kind of ionospheric scintillation simulation and kind of testing then the development and kind of coding around GPS and GNSS systems. And as I mentioned before, students are a huge key to our research, and they get involved with a lot of things and making trips. So, and I mentioned this is some of our researchers and students down in South Pole in Antarctica installing that the ALPIP system there. Sorry. As well, we've had a graduate student go to Svalbard in Norway. If you haven't ever been familiar with where Svalbard is, that's a good thing to look up and to see. It's one of the few places where I can't remember if it's required, but there's something about there's a large kind of like rifle ownership because they have to fend off polar bears on Svalbard. So, or you know, you have to be, I guess, not to, you have to fend them off, but you have to be kind of ready for that kind of event. So, continuing kind of clockwise here, this is um, Dr. Scales and some students at the HARP facility in Gakona, Alaska. And I can tell you the guy who's next to Dr. Scales there is, of course, I've got a blank on his name. He's a VT alum who was actually involved with designing the transmitters that are in at HARP, and does a lot of the kind of day-to-day operations and kind of maybe not day-to-day operations, but a lot of the kind of bigger maintenance projects, and certainly works on that. So other two more CubeSats that we have either upcoming or have had are here on the right side. The first of which is ThickSat. Stay tuned in the future, very near future, for that. Is that that CubeSat will be launched within the month. I think we're looking at February 20th for the launch date from that, from the Eastern Shore, I believe. But we'll have other information on that. But that was an entirely student-built project between undergrads and graduate students. And it's a very kind of small, compact system, as you can see there. In comparison, the series CubeSat is down here in the bottom right. This is part of the Virginia CubeSat constellation, where Virginia Tech, UVA, and ODU all made a CubeSat and launched them into space. And launched them to they were launched to the ISS, or they were rode up to the ISS and then deployed out of the International Space Station. And that was one of those ones where it was the goal of the mission was to study what the ionospheric drag models were like for those CubeSats. As we mentioned before, certainly students get up to Poker Flat, Alaska to join Dr. Scott Bailey with the sounding rocket missions there, and have a lot of fun. Those missions are very interesting because they have to wait for nighttime conditions. So they're oftentimes up at 1 or 2 in the morning out in the winter of Alaska, where the sun rarely ever comes up, kind of thing. As well, we have a ground station that's actually here in Blackstone, or Blacksburg rather, that we've been working on, and there's several different components to that I could spend another hour because I've been working a lot with that. And lastly, to complete the circle here, is a SuperDARN site up in Labrador, Canada, that we were up replacing some coax cable for. But we take students along with us on those maintenance missions where we can. So. And then one of the things that's kind of a slight update for even some of our current grad students or students is we've recently moved back to campus. Before, a lot of this work happened in a facility out in the CRC here in Blacksburg, but we've recently, as of the last, or in the last couple of months, been moving back to campus and getting our facilities set up. So now we're largely located between the 3rd floor of Durham, which we've joked about. We would, if we could, we would put a big banner out here on the 3rd floor, right? And this is pretty much where we're located. Most of the officers are located in SpaceVT, or for SpaceVT. But we're largely there with our professors' offices, as well as 2 different areas within Whittemore, between a 2nd floor lab, which has 2 room numbers, but it's pretty much one big room, and as well on the 6th floor is 619. And yeah, there's a lot of these facilities that you see here. Some of them are up and running again, especially the vacuum chambers, as there's ongoing kind of pressing research for those. The other ones are in the process of getting set up because we've had to do some modifications to the rooms on campus to get these, get a lot of this equipment set up, as they need certain, special power, circuits, electrical circuits rather, and as well, maybe sources to water or to air and that kind of thing. So a lot of these are upcoming, and it's certainly a part of work. It's a non not insignificant amount of work to get the what we had kind of is we've got all the parts and pieces, but put it all back together and get it working again. And that's certainly a room, or that's room for graduate and undergraduate students to kind of get their hands dirty and work on something in real life. So switching over to more classes and curriculum, here's all listed of the classes that we have that kind of relate to the SpaceVT Center, and certainly SpaceVT faculty teach, as well as what I believe is included into, there's two in the bottom right here, two kind of majors or technical tracks, depending on which department you're in, that you can take. And ECE, it's an electrical engineering degree, and you have a space systems major. And within AOE, it's part of the aerospace engineering program, and it's called a space engineering technical track. So if you're an undergrad student kind of listening or watching this later, and you're interested in that, certainly those are things to check out. So, and I think that's everything that I have. Visiting here is I guess in a real world, when we could get together, maybe this would have been an actual tour of our facilities. But thanks for listening, and I'll certainly take any questions or additional comments for any of the other, maybe where I goofed up or had some errors. Any comments or questions or general, any questions at all for things about the center? Seeing a chat come up here. Is it possible, a question come up, is it possible to visit the facility? I think, in our current COVID guidance, I think what we would be able to work out is maybe on a one-on-one basis, or maybe a very small group basis. We might be able to have, give some tours and kind of certainly show you more than what the current just pictures are. We would probably be able to handle that. Probably myself or Debbie Collins would be great to email to try to arrange that. If there's a particular, what I would encourage maybe is to look through our SpaceVT site, and as well, and maybe looking at sort of this list of what our core research groups are. And another way that we could kind of try to pare that down, or think it might be more possible, is trying to coordinate with some of the researchers here, and particularly if there's something that you've been particularly kind of interested in, that they could give you some tours. I will let you know there's some on here that are kind of purely not remote, but they don't have something kind of set up here in Blacksburg. One of those that's jumping out at me is the MIST team, or the MIST group, where they have some hardware here, but a lot of their hardware ends up being deployed in Antarctica, because if it's sitting here in a lab in Blacksburg, then it's not taking good measurements. So a lot of that ends up just coming here briefly to test out and to check out, and then it heads on its way down south. So hopefully that answers the question. So yeah, I guess to say the short of it is yes, you could tour it, email myself or some of the researchers or some people that you might find on the SpaceVT website, and we can try to set something up if it's like a smaller scale kind of thing. That's a great question. Anything else? Any other comments? Any corrections, errors that I've made from? I see there's a number of familiar faces and people who are or anything that I've missed too. Anything the current researchers or students, grad students that I've not highlighted here that you kind of want to bring up for people who haven't been around.
Yes, Mike Rahanami here, involved with the SuperDARN group. I'm the first name listed there under SuperDARN HF Radar Lab. I just mentioned that opportunities for research experiences are available and coming online, being announced. You may want to pay attention to some of these. We have listings of them in a couple of places. And you can talk to any of the faculty about what's available and whether it's the right match for you. So lots of students get practical research experience this way, travel to sites. In the era of COVID-19, I'm not sure what the status of that travel is, but I am aware that most of the schools are operating through the summer.
Yeah, so that's a great point, Mike, and certainly, yeah, if you're interested, then yeah, and even if there's not travel, there's plenty of things that can be done in the labs, and some of them, right, where travel is not really possible or is not part of it. Like I said, there's some kind of active research right now with some of the vacuum chambers in the plasma, where basically what they do is they kind of take this big vacuum chamber and pump it out, and then create basically controlled plasma within the vacuum chamber, and then do some kind of studies on how that works. So, or kind of what happens to it, and doing measurements with maybe some lasers and that kind of thing that kind of run through there. So there's certainly a lot of work that can be done without ever leaving Blacksburg. So. But yeah, it's a great point, Mike. I'll give another pause or opportunity for any of the other people to see if there's anything that we've missed. I know it's always tricky for me to find the mute button pretty quick, so sorry if it's a longer, awkward pause, but not hearing anything, we'll call the session closed for now, and I'll give everybody maybe 20 minutes back of some time, which they might really rather enjoy. These seminars don't always have to be the full hour. Certainly they can be kind of shorter and to the point. And in a way, a lot of times too, the shorter ones will kind of open up for more discussion points. So with that, I'll close for today, and I'll hang out for a little while. Anybody has any other quick questions or comments or that kind of thing. So thanks so much for everybody for joining, and we'll talk to you next time. We will be hearing actually from Loft Orbital. Let me pull that up here really quick. By somebody in Loft Orbital, and that will be 2 weeks from today at roughly 2 p.m. I'll send out some information on that when that becomes available. So otherwise, thanks everybody for joining, and we'll talk to you in 2 weeks.